Welcome to my presentation. In this presentation, we shall see how to simplify exponents containing variable expressions. So let's start with a simple example. Let's say we have a variable expression given to us and we want to evaluate x to the power of 2 times y to the power of 2 when the values of x and y are given to us as follows. When x equals to 2 and y is equal to 3. We want to be able to apply the exponents concept to this problem. So what do? Step number one, we're going to first substitute the values of the variables into the given problem. When x equals to 2, we can write the first term as x to the power of 2, and when y equals to 2, we can write the second term as y to the power of 2. If we were to put these things together, the given problem will become 2 to the power of 2, and then the y term is 3, and therefore the second term will be 3 to the power of 2. So that is how we're going to replace the variables by the given numbers in this particular problem. In step number two, we're going to recognize what the base term is and what the exponential term is. For the first term, the base term is 2 and the exponential term is 2. And for the second term, the base term is 3 and the exponential term is 2. Now we want to be able to apply the concept, and then in step number 3 we're going to apply this concept. We're going to raise 2 to the power of 2, and then we're going to raise 3 to the power of 2, like that. And now we're going to expand these with respect to the concept we talked about. The first term 2 is going to be repeated 2 times. The second term, which is 3, is going to be repeated 2 times, and therefore that is how we can write it. And therefore we're going to simplify this math. 2 times 2 is equal to 4. 3 times 3 is equal to 9, and therefore 4 times 9 is equal to 36. 4 times 9 is equal to 36, and therefore this is our answer. So what have we done here? Let us recap. We've been given an we have in this particular problem we see that the variable expressions are given to us in the form of x squared times y squared, and then when we are given the values of x as equal to 2 and the value of y as equal to 3, we're going to substitute them into the given problem and then write it out in exponential format. The base term is 2 and the exponential term is 2. For the first term, the base term is 3 and the exponential term is 2 for the second term. So we recognize the base terms, we recognize the exponential terms. In step number 3, we then applied the concept. The concept is the number of times the exponential term is given to us in the number of times the exponential term is given to us in the power term here, and therefore we're going to expand it out. 2 times 2 is equal to 4, 3 times 3 is equal to 9, therefore 4 times 9 is equal to 36, and therefore that is where we're going to leave it. Let us look at another example. Let's say this time we have instead of whole numbers we have fractions. Let's say we want to evaluate a squared times b squared when a is equal to 5 over 6 and b is equal to negative 3 over 5. Let's say we have a problem of this nature, and now the variables are in terms of fractions. It doesn't matter. The concept is exactly the same. In step number one, we're going to substitute the values of the variables given to us in the given problem. Wherever we see a, we're going to substitute 5 over 6. Let's write that down. 5 divided by 6 raised to the power of 2. 5 raised to the power of 6 raised 5 over 6 raised to the power of 2, like that. And then b is negative 3 over 5, that is the base term, and that is repeated 2 times. So that is how we're going to write it down. And now we're going to, this is step number 1. In step number 2, step number 2, we're going to recognize the base term and we're going to recognize the exponential term. For the first term, let's write it down. The base term is 5 over 6 and the exponential term is 2. For the second term, the base term is negative 3 over 5 and the exponential term is 2. And now we're going to apply it to this particular problem, and then step number 3, we're going to recall the concept, and the concept is telling us the number of times the base term needs to be repeated is given to us in the exponential term. So therefore we're going to expand the base term the number of times the exponential term is given to us. So therefore in the first term we're going to repeat 5 over 6 2 times, 5 over 6 times 5 over 6, like that. And the second term, the base term, is negative 3 over 5, and we're going to write it out as 3 over 5. Since the power is 2, we're going to repeat that 2 times, negative 3 over 5. Now it is just a matter of simplifying the math, and therefore when we do that, we're going to multiply the numerators, multiply the denominators. We'll take 2 fractions at a time. 5 times 5 is 25, divided by 3 times 3 is 6 times 6 is 36. Then we're going to take this part of the fractions and then say negative times negative is a positive, 3 times 3 is 9, and then divided by 5 times 5 is 25. We need to simplify this part of the equation. So when we simplify this, we're going to multiply the numerator parts, multiply the denominator parts. Let's write it together this way. 25 times 9 divided by 36 times 25. We mentioned before that if we have numbers in the numerator and numbers in the denominator which are multiples of one another, we can simplify them. 25 times 1 is 25, 25 times 1 is 25, 9 times 1 is 9, 9 times 4 is 36. So therefore what we have here is 1 over 4, 1 over 4, and that is our answer. That is where we're going to leave it. When we had an exponent of this format, which is in the form of a variable expression, a squared times b squared, and the values of the variables are given to us as fractions in this particular problem, where a is equal to 5 over 6 and b is equal to negative 3 over 5. When we have applied the concept in here, we have substituted the values of the variables. Then as step 2, we have identified the base term, identified the exponential term, and in step number 3 we have applied the concept, and then we simplified the math and we were able to get the answer. And this is how we're going to simplify exponents which have variable expressions. In my next presentation we shall see how we can use exponents to solve real world application problems.